Well, hello there, and welcome back to another very exciting installment of trying to finish a demo in less than... How many days do we have left now? We have 29 days left. That's crazy. It's not enough days. We should have more days. Make more days. Well, until we can make more days, we gotta do what we can with the days that we have. This is the worst intro. Today I did some programming, which is exciting. You know, it's the stuff that we love to do. It's the stuff we love to see. Again, lots of I would say foundational stuff. The couple highlights that I'll walk you through today were automating downloading of assets. As I mentioned yesterday, we're working with a studio to produce a lot of our art content, and what I wanted to do is just make sure that it was super easy to pull that content in. So I'll quickly walk you through how we did that, and hopefully you'll find that interesting. After that, still on the vein of assets, is worked on getting material properties from the assets to be reflected in the renderer, which is something that you probably want. Normally, or I guess like in the past, we haven't read properties in that same way before, and so we just wanted to do that and make it nice and simple. Waffle. And in the process, just worked on the render and found like a couple of tweaks here and there that could be improved, and also some stuff to do with live reloading of assets. And then finally finished off today with improving some of the controls and the way the camera handles that have made a huge difference to how the game plays and feels, that I think you'll very much be able to see the difference. So yeah, let's jump into it. So this is our production spreadsheet. Don't try and copy the URL and peer into a shit, it's all protected, you weirdo. But this is a spreadsheet that I made to keep track of all the shit that's in the game. The idea here is that pretty much everything that's in the game is in the one place, and so it just makes it easier to keep track of all the crap, you know? Like, even for a game as small as Clipper, you'd just be surprised like just how many things there are, you know? So I think at some point I would love to talk about how a lot of this stuff came to be designed and how we thought about it and all that sort of stuff. But like, just for today, I want to just focus on how the spreadsheet is used to keep track of assets. So I have never worked in a game studio before, and I don't have any professional game development experience. I mean, this is all completely insane and completely wrong, but from sharing this around with some people who work in production, you know, this seems to be something that is not that far from what's used inside of quote unquote real studios. So the idea here is that every 3D model that ends up in the game is recorded somewhere. And so when you're working with like an external group to produce your assets, you want to be really specific about the things that they're making. You know, things like the dimensions, like how big should they be, how much space should they physically occupy, and then things like references and so forth, to give the artist, you know, a good dare I say reference for when they're creating things. So not everything is done yet. You can see there's these things in TBD where like I didn't even know, like, okay, I know we're gonna have a bunch of buildings. What are those buildings? Well, you know, don't have them all there yet, but at least knowing that that's the amount of things that we need to make makes a huge difference. Knowing that it's 20 and not 2000 is huge. So the way that the process works is we have the spreadsheet, the artists, like they pick up an asset that they're going to work on, they change the progress or the status to like work in progress, and then when it's done, they post a Google Drive link that contains the actual model that can be put into the game. And so rather than because there's like 60 odd models that we have to download, and they're going to be changed and updated all the time. We put in feedback and ask them to iterate. Instead, what I've done is I've automated the process of scraping this spreadsheet, pulling all the data down, and downloading the actual asset. So I'll walk you through how that works. Okay, so Clipper is made up of a bunch of different crates. There's way too much to go all over in this episode, but needless to say, there's a bunch of stuff that goes into making a game. I don't think I've even mentioned that that the game is written in Rust and is like kind of a game with an engine. The engine's sort of part of the game. I should probably go into that at some point, but needless to say, for now, it's a game that's written in Rust and there's a bunch of stuff in it. And one of those crates is the really, really cleverly named data fetcher, because what it does is it fetches data. So what we do here is we use the Google Drive API to pull down the spreadsheet. There's a bunch of data that we fetch, but one of the things that we download is the model sheet here. And once we do that, we walk through every row so if you remember back in that spreadsheet, there was a field in the spreadsheet. I'll pull that back up just to be super clear. There's a field on the spreadsheet that says asset link. And so what we can do here is walk through each of those rows. We look to make sure that there's an actual link. We pull out the file ID, which you can see here is like the bit after the D. And then we download the model. So this is all of this stuff is happening inside of Tokyo. So this is all like asynchronous stuff with futures, or we can do this in parallel. And what we do here is we use the Google Drive API to pull down the file. Which was surprisingly annoying to do. Google's APIs are pretty idiosyncratic. But anyway, we get the file down, and then the files are all zip files. We use the zip crate to deflate rather the zip file. We look through the zip archive here. You can see that we look through all the file names. We find one that ends with GLB, which is going to be a GLTF model, which is what we use in the engine. And then we find the file, and then we do some things where we replace the file name. The artists, for whatever reason, they've put ID underscore in front of the name of the model. We don't care about that. And then we just write the model to the disk of this path, assets models file name. And so you can see in assets and models, we have all of our models there, which is really cool. And we've got this like consistent and simple naming scheme where every asset has an ID, which is just a number, and followed by its name, so it's easy to do. And so I can even like look and preview these models from inside of VS Code with the GLTF viewer plugin, which makes life super easy because I don't need to like jump to another application to like actually preview them. And yeah, they're coming along really well. I'm very pleased with the progress that they have made. So that's all really cool. And so then with all that naming convention set up, it's just a matter of making sure that everywhere in the code that tries to spawn a model is using the correct convention and all that sort of stuff to look up the correct model from the path. So, you know, like not the most exciting or sexy code in the entire world, but like really useful because now we can just run one command and we get every asset that's used in the game right there ready to go, and there's no messing around with you know, Blender or any other 3D tools or any of that sort of stuff. So yeah, coming back to that stuff about like, what do they call it, brushing your teeth, talking about like the Steam builds, like this is the stuff you want to do. You just want to make life easier for yourself. So yeah. All right. So with that out of the way, I'll dive into some of the other stuff that I did today. Okay, so next up is the rendering stuff that we did. So the renderer for the game is a Vulkan-based renderer. Vulkan is awesome. Anyone that has spoken to me for more than 4 seconds about graphics knows what a complete psychopath I am for Vulkan. We currently use GLSL for our shaders. I'm not the most happy with it. I'm always looking at Rust GPU as an alternative to use in the future. Maybe even HLSL, but in the meantime, GLSL is what we're using. So we use, as I've mentioned a couple of times, but probably not in any coherent way, we use a physically based rendering, I don't know, material model that comes with it's sort of built into the GLTF specification in a way. And basically that works by a model. So like say for example, we don't really have any like complex models to demonstrate this with, but you can imagine a model has different textures that determine the color. So for example, like this t-shirt would have like a nice like maroon base color. But then the way the PBR model works is it has these two other parameters, metallic and roughness. And roughness basically lets you set how reflective the surface is. So, you know, something that is zero roughness would essentially be a mirror. And then metallic basically determines, there's some really interesting ways that light and metals operate. Like a surface that's perfectly metallic actually doesn't emit any of its, doesn't have any color, so to speak. Like it doesn't reflect any light. I believe gold is one of the only exceptions to that, but these are all, you know, weird, esoteric things that are left to people much smarter than me. But for my purposes as a simple programmer, these are just like values that are stored in a model that we plug into our, you know, into our shader functions. And so traditionally in the past, when I've worked with GLTF, I've worked with models that are authored, like sort of, you can think of them as like more photorealistic models that have a separate texture set for the roughness and metallic values. And what that means is you can have a single model that has like really detailed like reflections and like dust and scratches and all that sort of stuff in it, and it looks really cool when you have it set up properly. But Clipper's art style is purposely quite simple. I think down the track we probably want to move towards that kind of model, but like the overall look and feel I'm going for is that everything should almost feel like it's a toy, like it's sort of made out of that like plastic kind of rubbery material. And so, you know, there's not that much variation over the total surface in terms of like the metallicness, like it's all made out of the same material. So what we want to do instead of having to have a completely separate texture that an artist has to author that has all these like different values in it, we can just have a single value across there. And so in the GLTF model, this is called a roughness factor or a metallic factor. So this is how it gets used in the shader. There's just a value here, roughness factor, a metallic factor, and we multiply whatever was in the texture, or if there was no texture, we just set it to 1, by this roughness factor to determine the final roughness or metallicness, metalness or whatever you want to call it, of the resulting material. And so this is how it's finally used in the shader, but it might be interesting to walk you through like how a value like this gets into the shader to begin with. So everything starts in the asset loader, which is where we are actually reading our GLB files and importing them into the game. So we have a function here called load material that takes a primitive, which you can kind of think of as like a part of a model, and it reads in the roughness and metallic factors from the model, which we put into our material, and then in the renderer, load material, I think it's in the renderer, we have a slightly different representation of that. I think it's called GPU material. Yeah, there we go. Same thing. We've taken this value from the asset loader, so this roughness factor. It's then gone into this GPU material struct. And then finally, when we draw our meshes, we create what's called a push constant, which is basically just some really cheap bit of data that we can use to push into our shader that we set on the material. We call push constant. We grab the material, and again, that has those properties. And then finally, that goes into our push constant layout. So again, this little roughness factor, which gets used here. So you can kind of see like the winding path as it starts here when the model's loaded, goes into the renderer code, goes into a push constant, and finally gets put into a shader. And so lots of graphics programming is that kind of stuff. It's like plumbing. Like you're taking something from one place and then moving into another, and doing that in a efficient way is kind of like a lot of the art and science of graphics programming. So yeah, nothing super crazy, but really helpful. And in the process, I sort of like was walking through some of our graphics code, and so found some little things to do with our directional lights. So meaning we have the lighting model is a little bit complicated. It's probably a bit too much to go into this video, but worked on some of the lighting, and now I think it's in a lot better spot than it was before. So yeah, that's all in a good spot. Then the final thing I worked on was adding like a free camera rotation, which is, I haven't pulled that patch down. Let's do that. Patch branch. Goodness, you're seeing it working live. Okay, so our camera has two properties to it. Well, two rotational properties to it. The yaw, which is where we rotate around the y-axis, and the pitch, which is where we rotate around the x-axis. Previously, all you could modify was the yaw, and you did that by pushing the Q and E keys, which kind of always felt like a bit gross, but like it was just a short-term thing. So now what I've done is I've added this function called get camera rotation delta, which is basically if the mouse, the middle click on the mouse is held down, we take the mouse motions and we translate that into some camera rotations. So we take the x-axis, which is moving left and right across the screen, we turn that into your yaw, and then we take the y-axis, which is moving up and down the screen, and we take that into your pitch. Simple, basic stuff if you've done game dev before, but you know, if you haven't and you've played any game that has like a 3D camera, it's kind of interesting to see how this stuff works under the hood. So I'll bring up the game and show you how that looks in practice. All right, so here's what we had before. So you might be able to notice that the game like looks a bit brighter and some of the colors are a little bit more vivid and consistent. It's just, it's a constant thing, like getting lighting and colors to look good and be consistent. But I'm a lot happier with where it is now compared to where it was. So anyway, as I said before, we middle click and then we can move up and down to adjust the rotation on that x-axis, and then we can rotate around. And I feel like just adding this makes so much of a difference to the way the game feels. You know, like I feel so much more like I'm in the world and I can see these, you know, little crazy things going on. It's such a small thing, but it makes such a huge difference. Obviously, as you can probably tell, you know, the character is walking, you know, strafing around. The character itself doesn't actually rotate. That's something I'll add in a little bit later on. But you know, I just feel like it adds so much more depth to the game, and I'm really happy with how that turned out. And then it took like a couple of minutes to actually do. Oh, while I'm here, I should demonstrate some of the stuff that we worked on. I say we, but mostly it's Alex, the guy who's sitting behind me yesterday, his work on pathfinding. So as you can see straight away, the Vikings saw that there was an obstacle in front of it and very cleverly routed around it. So it's, you know, it's something that you completely take for granted when you're playing games, but being able to actually navigate around obstacles. In that case, I think the bike was a bit too small for him to notice it was there. But having that work just again adds such a difference to the feel of the game. So next up is going to be adding some of those same things that we have for the Vikings, adding them to the player controller. Like right now, the player can still like walk through objects, and the player isn't actually orientated in the correct direction. So what we'll want to do is just add some of those same things there so that you can't walk through objects, and the player's character is always facing in the direction that's heading. So that's everything that I did today. Lots more stuff to do, but you know, just feeling good. Can't, you know, I know that I'm gonna get more freaked out and more head pulley later on, but right now, feeling like I'm making good progress and the things that we're putting into the game feel good. So yeah, happy with all that. As always, thanks for watching. If you'd like to support my stuff, check out my Patreon in the link below. There's some cool things that you can get in there, like access to the game source code, nightly updates of the game, or weekly, whatever I said. And just being able to support my work is something that I would really appreciate. So thank you very much if that's something you decide to do. All right, bye for now, and I'll see you tomorrow. Thanks for watching.